Good afternoon to you. Mark Sudduth, HurricaneTrack.com, here with your hurricane outlook and discussion for Thursday, June 14th, 2018. Tropics generally quiet today. We do have invest area 91L that really isn't going to amount to much in terms of an identifiable tropical feature. It will bring a surge of moisture, rainfall, of course, associated with that. Two portions of the Gulf Coast, the western Gulf Coast, that is. And, of course, we have to keep a watch on what's happening with Bud, weakening Bud in the eastern Pacific. Let's drop me out for just a few minutes. I'll come back in a little while, at least the visual part of me. There's the yellow X in the southeast Gulf, I guess in this case the Bay of Campeche, southwest Gulf of Mexico. And you can see it's 10% chance of development overall. Really not going to amount to much, as I alluded to. We click on it, zoom in just a little bit. Elongated area of cloudiness, showers, and thunderstorms. And let's get the pointer a little bit better oriented here. A lot of moisture associated with it, but not organized at all. And therefore, this, unlike what the GFS was advertising for this weekend, is not going to be a hurricane for the upper Texas coast, or any coast for that matter. Looking at the, hey, we already did this. Looking at the, a little bit further to the west, the satellite shot here of Bud, weakening Bud as it moves in towards the Baja. Some shower activity, heavier rain bands from time to time, maybe some gusty winds, choppy seas, and as I said yesterday, just take this time if you're down at Cabo San Lucas to relax, chill out, and enjoy the tropical rainfall and light breezes, and be very thankful that it's not a repeat of Odile from 2014. Now, moving to the Gulf of Mexico, this is what I wanted to show you a second ago, but I got my slides out of order. That's fine. A big mess overall, nothing organized through here, but this is going to move up towards the Texas coast as the overall pattern evolves and allows this surge of moisture. And there will be an increase in some heavier rain chances, especially with any thunderstorm activity. Remember, the convective activity is what drops the heaviest rain in these systems, so just be mindful of that. I know in the Houston area and elsewhere, certainly a lot of jitters and anxieties when we mention anything tropical related headed your way, and even these rainfall amounts that I'm seeing, though they could be several inches, will not be anything that you can't handle. So take a deep breath and don't worry about it too much. Yes, you're going to get some rainfall, but it's needed in a lot of areas, and luckily in this situation it won't come with any wind or storm surge issues, nor a prolonged flood event. So look at it that way, the benefits without any, hopefully, or at least minimal amounts of any of the negative impacts. Looking at the vorticity signature, you can see it's stretched out, okay, not round in its appearance at all. Here's a disturbance in the eastern Pacific, probably not going to do much as over the next few days it'll dissipate. Here's the vorticity signature of Bud, and there's the Vort Max, or the vorticity signature of Aletta, still hanging out. And again, I'm going to be curious to watch this as it moves on across the Baja and then eventually up into the southwest United States. We will see what kind of signature remains. Heavy rain will spread across this region, as I have been mentioning quite often over the last several days, so just be mindful of that. All right, sea surface temperature charts updated today, at least from the NOAA NESDIS site. They do Monday and Thursday. And so here is the June 14th edition, and the main development region filling in just a little bit more. And if we compare this to 10 days ago, you can see what I mean there, especially in the far eastern Atlantic over here near the Cape Verde Islands. Pay attention to this area right through here. That area has definitely moderated from, there it was fairly cold relative to average, and now we're getting much closer to more reasonable mid-June water temperatures. Still a long way to go, and whether or not this fully recovers by August, September, we will have to see. A lot of that will have to do with how strong the Bermuda Azores High is, in this case the Azores High, this big subtropical ridge that can pump lots and lots of not only strong trade winds across the tropical Atlantic, keeping things mixed up, but it brings off those African dust plumes, and that can help to cool things off as well. Now, looking at the Madan Julienne oscillation, the MJO Right now, it's generally in the null phase, as we like to call it. Forecast to move out and amplify into phase 1, and a lot of these ensemble members indicating phases 1 and 2, which is generally favorable for Western Hemispheric and Africa, convection over Africa, and the GFS and its ensembles, though not as many members. The Euro has more ensemble members, as you can see. Also favoring a general trek into phases 1 and 2, but it's very weakly amplified. You see that? It's very weak. And whether or not this triggers development down the road in a couple of weeks, we'll just have to wait and see. And then we also have this. And what is this? Well, let's bring me back just for a moment. All right, so do you remember, I don't know, is it still on, that show, Who Wants to Be a Millionaire? Very popular on ABC, started in 1999, and they had this thing on there, this part of it where if you were stumped on a question, you could phone a friend, and you could get yourself sort of out of a bind by phoning that friend. Well, to explain this graphic and a little bit more about the MJO and what this is, which is showing the what's called a convectively coupled Kelvin wave, some of these things go beyond my ability to answer these questions. So I thought, well, let's start bringing in some experts. I don't know everything, and I certainly hope I don't come across as pretending to know everything. And when I certainly don't know everything, I think it's time to phone a friend. So what are we going to do? I'm going to bring in this guy, Dr. Michael Ventrice, all right, the weather company and IBM Business, PhD in tropical meteorology. I think that's a great idea. So let's get rid of me, and let's go over here, and let's bring him up. And there he is.
Hey, how's it going, Mark?
I am doing great. Thanks for joining me, everybody. As I said, I kind of phrased this as phoning a friend, that some things I don't completely understand them, and like on that show, Who Wants to Be a Millionaire, when you don't have the answers, you phone a friend. And I feel like I've gotten to know you very well over Twitter over the last several years. So I thought it's time, when you have a PhD in tropical meteorology versus my degree in geography, you win and you know more. And I thought, let's do it. Let's ask Dr. Ventrice about a couple of things. But before we get started, just tell us a little bit about yourself. I did a brief intro before I Skyped you here, but lead the way.
Sure. So I work at the weather company, which is part of the IBM, which is part of IBM now. We were formerly known as Weather Service International. That's when I was hired back in the energy team, where I was dealing with a lot of folks trading natural gas and power. And since then, I've moved into more of a prominent analytic role within the company. Now, a little bit of background on my PhD. I did receive both a bachelor's and a PhD from the University of Albany, where I did work under Dr. Chris Longcroft and Paul Roundy. Dr. Paul Roundy, see him on Twitter as well. So a lot of what I have known is essentially a reinvention of the wheel, I guess you could say, with Paul. So Paul's
Gotcha.
a lot of the Tropics.
Well, what we want to talk about today, I want to try to help the folks that watch these video discussions understand a couple of phenomena a little better. I try to describe them as best I can, but again, when something's beyond my reach, I think it's wise to reach out to others who may know more. So the first one is the Madan Julienne oscillation. And if we can try to break this down, as people that watch my videos know that I do a lot of analogies. Some of them are good, some of them not so much. Some of them relate around food, some of them are sports. It just depends. But it really does help people to get a better grasp on a concept that may be alien to them. So the Madan-Julienne oscillation, in the best way that you can describe it, what is it and how does it affect tropical cyclone genesis? And even if they can thrive in an MJO period that's favorable versus one that's not favorable.
Sure. So I'm going to start off with the academic definition
Okay.
that I'm accustomed to, and then kind of try to attempt an analogy or metaphor. So Madan-Julienne oscillation is a baroclinic circulation that couples with large-scale variations of convection in the tropics. All that means is you have an area favorable for thunderstorms, and you have an area of convergence, rising air, and an area of divergence aloft.
Gotcha.
And then on the other side of the hemisphere, you have sinking air or substance, which is then promoting sunny skies or suppressed convection.
Right.
For a metaphor, I always tell my clients, you can think of it as like a massive butterfly flapping its wings over a particular location near the equator. And, you hear about the butterfly effect. This causes downstream rippling effects in circulation across both the northern hemisphere and the southern hemisphere. So, in addition to tropical cyclone modulation of activity, the MJO can also be used as a predictor for circulation about the northern hemisphere. So using it as, the MJO is here today, what's going to happen in the next few weeks?
Gotcha.
So regarding tropical cyclone activity, the MJO is actually one of the main forms of intraseasonal variability or week-to-week variability of tropical cyclone activity across all basins. When I first started doing this work, there was a lot of skepticism of the MJO or Kelvin waves, for that matter, impacting the Atlantic basin. But I think I've done a good job of punching through the community and opening some eyes and saying, hey, these waves do actually in fact get across my basin. So there's a couple of things. I'm just going to focus on the Atlantic basin and tie it into how this impacts it. So during particular MJO phases or states, I guess is a better way of saying it, when it's located over a location, you see a number of environmental changes over the large-scale tropical Atlantic that is more conducive. Typically, when you have that low-level convergence ahead of, or co-located with the active phase of the MJO,
right.
If you put that over Africa or the Indian Ocean, you have a fetch of low-level westerly winds that's essentially reducing the trades over the tropical Atlantic. That does two things. It acts to reduce the vertical wind shear over the Atlantic.
Sure.
And it also acts to increase the background spinning. Or
the vorticity. Right.
Yep. Those are some of the main things that the MJO can do dynamically that impacts
Interesting.
The large-scale environment. It also can increase large-scale vertical moisture. So usually you see when after the MJO passages, the tropical Atlantic is less dry, which is helpful for developing storms.
After it passes.
That's correct. So
interesting. Okay.
So it's when it's passing and then after it passes.
Right.
And that's because we're getting into the next section of what I want to talk about.
Yeah.
That's the role of the MJO in Africa.
Okay.
So we know that tropical cyclones have to be seeded, right? They develop from incipient disturbances, and there's been a lot of good work in recent years. I did some of that work as well. That looks at how the MJO can impact African easterly wave activity.
Right.
So we often see the MJO, when it's passing Africa and after it passes, it convectively triggers African easterly waves. And there's also some modulation on the African easterly jet, which allows these easterly waves to develop baroclinically and barotropically. So by enhancing Africa and spinning off these seeds into the tropical Atlantic, and now we have a semi-pseudo more favorable environment for developing tropical cyclones, we have essentially the loaded gun and the bullets firing off into the Atlantic. So
interesting. I always thought of it as just a period of favorable upward motion, and I didn't understand, and this is hence why you're here today, to sort of further define its role in, like you said, the vorticity and the seeding, especially when it's happening over Africa. And I never realized, too, that once it passes, that the environment left behind, I presume then, is generally favorable for development. How long does that particular favorability period last?
It can vary case to case. On average, it's about probably 1 or 2 weeks.
Okay.
So actually, the strongest signal with the MJO when regarding to the Atlantic Basin is not necessarily the genesis, though there is a signal there. It's actually if you were to count the number of hurricane days or MJO phase, you would see a significant increase in the frequency of hurricanes over the Atlantic Basin when the MJO is over the Indian Ocean. So
interesting.
It's actually 4 times more likely for a hurricane to be active over the Atlantic Basin during the summer than when it's over the western or the central eastern Pacific.
Very, very interesting. And so that leads us to the next part that I've seen you tweeting a lot about the last few years, and that is this convectively coupled Kelvin wave. And boy, I've really tried to wrap my brain around that, and I've had a tough time. And so again, I'm going to defer to you. So you've done a lot of work with that, so I'm very excited to hear about this, and hopefully this will allow me to talk about it further down the road in my discussions as well.
Sure. So if it wasn't for Kelvin Waves, I wouldn't be here today. That's honestly,
How about that?
The truth. When I was back in grad school and I started working on Kelvin Wave research, I did get a lot of lashback from my peers, I guess you could say. A lot of jokes. I was known as the crazy Kelvin Wave guy. But, I decided to really kind of just buckle down and do the statistics and work on it to help everyone else understand the field.
Sure.
That there's something going on here, because it's a common theme to see meteorologists be very skeptical of new ideas. And that's like maybe a message I would love to say to all future meteorologists or even people in the field, to be receptive to new ideas, because obviously there are things we don't know about the weather.
Right.
So Kelvin Waves, actually, I can. How long do I have here? I mean,
as long as we need. Yeah.
Okay, cool.
This is YouTube. When it's all said and done, we can go for. I mean, kids watch Fortnite, people playing games and whatever for 10 hours at a time. So.
Okay. Cool.
Not that we're going 10 hours, but you got as long as you need. Absolutely. This is fascinating.
Okay. So, when I was starting my research, actually, I wasn't supposed to be investigating Kelvin waves at all. I was signed on to do understand the diurnal cycle of convection over West Africa. I was under a NASA grant with Chris Donkoff. And I stumbled upon a really good case study of a Kelvin wave interacting with the West African topography, impacting the diurnal cycle of air, and phasing with an easterly wave that then developed into Tropical Storm Debbie in 2006 off the coast of West Africa.
Gotcha.
So there was a lot of, I guess chance, you could say, that, I really kind of went forward with this research, and the University of Albany was great for allowing me to kind of move forward and do all that. But so Kelvin waves are similar to the MJO.
Okay.
But they're spatially smaller. So we define spatial characteristics through wave numbers when we talk about tropical waves. So MJO is commonly noted as a wave number 1 phenomenon, meaning there's one area of rising air on one side of the world, tropics, and one area of sinking air.
Okay.
Kelvin waves have a higher wave number. So there can be multiple Kelvin waves pushing across, spanning the equator at a particular time.
Okay.
So there's more frequent numbers, and they're spatially smaller. So, the active phase of the Kelvin wave will not cover one hemisphere. It's actually much smaller.
Makes sense. Okay, right.
The second thing that essentially makes the Kelvin waves different than the MJO is they propagate to the east at a faster phase speed.
Okay.
So the MJO takes, depending on the base state, if it's over the warm pool or not, the MJO can propagate anywhere from 6 to 12 meters per second.
Okay.
To the east. Kelvin waves are typically faster, anywhere from 12 to 20 meters per second. And actually, when they're not coupled with convection, when they're predominantly stratospheric waves, they can move at the order of 50 meters per second. So that's actually something that's a good point. Kelvin waves are also, so they propagate to the east, but they're also propagating into the stratosphere.
Interesting.
So there's
in the vertical, right. All right.
Yeah. So there's a lot of work that is starting to tie in Kelvin waves with the quasi-biennial oscillation, stratosphere warming episodes, etc. So there's a lot of things we still don't understand about these waves. So when I did my research, it was just specifically focused on the role of tropical cyclone formation. So regarding these waves over the tropical Atlantic, it is similar to the MJO. These waves do trigger African easterly waves over preferable locations in Africa where there's elevated topography. You have the Guinean Highlands, the Darfur Mountains, the Ethiopian Highlands.
Right.
So when the active phase of the Kelvin wave moves over one of these mountain ranges, you usually see a westward propagating African easterly wave convectively trigger and then take off across West Africa.
Okay.
And there is a window of favorability as well that is left in the wake of Kelvin waves. It's maybe a 1 to 3 day window that you could change the large scale environment.
That's shorter. Okay, right.
Yeah. Typically, the relationship with Kelvin waves and tropical cyclogenesis is you typically see an enhanced uptick in activity, developing storms about 2 days following the passage of the active phase of the Kelvin wave.
Gotcha.
So this threw off a lot of folks in research. What a lot of folks do is they look at genesis within the active envelope, and then everything outside of it, they throw it out.
Gotcha.
So since Kelvin waves are pumping so fast,
Right.
2 days later it could be 60 degrees of longitude to the east of where it was.
Sure.
On a particular day. So what was happening is we'd see these Kelvin waves push across the basin, and then you get these waves that kind of pop out outside.
Right.
And that could be an initial wave or a superposition with the initial wave that then develops in tropic cycle later in time. But so that's why a lot of people in the industry were like, hey, Kelvin waves don't have a role in tropic cyclogenesis, but if you were to do a lagged analysis, like I did in my PhD dissertation, you would find the relationship that you have more enhanced tropical cyclogenesis about 2 days following the passage of the Kelvin wave, rather than co-located with the active phase.
But the Kelvin wave itself doesn't guarantee genesis, just like the MJO being in the favorable, or some people call it the wet phase. Sometimes it just doesn't work out for whatever reason. There are other mitigating factors. But I guess you can also have an MJO and a Kelvin wave. Can they kind of overlap each other and then sort of give you a super trigger?
You are opening a can of worms, my friend. So yeah, in the research that I did, looking at just strong Kelvin waves, typically it's co-located with the convective active phase of the MJO.
Okay.
Now, there's a caveat here, and this is going to start to get really complex, and I'm trying not to avoid it, but it needs to be said. The MJO active phase is often composed of a single strong Kelvin.
Okay.
So, typically when you have these big, strong Kelvin waves, and it's usually over a preferable location that's favorable for thunderstorms in the tropics, so like the West Pacific warm pool,
sure.
Sometimes the Indian Ocean warm pool, etc. The Kelvin wave will slow down. So as you get more convection coupling with the Kelvin wave, it actually changes the phase speed, slow it down to be morphed into what looks like an MJO.
Very interesting.
So,
wow.
Yes. Yeah, so it's complicated. So over the Western Hemisphere, where the Atlantic Basin is, typically the background environment is not favorable for thunderstorms along the equator.
Right.
You get cold sun that develops both in the East and the East Pacific and the Atlantic, so that makes it very difficult for the Kelvin to really kind of couple with convection. Though you do see that enhancement of convection in the mean location of the ITZZ. So that what happens is the Kelvin wave speeds up, right? It's less coupled with convection than it was over the West Pacific or the Indian Ocean, so it speeds up. And then once that Kelvin wave moves over the Indian Ocean now, that's where you see it move back over that favorable environment, which then it slows down, it couples with convection, and it morphs back into an MJO. So right now is a great example of this.
Right.
We're seeing a very strong Kelvin wave push across the Eastern Pacific, the Atlantic Basin, it's over the Atlantic Basin today. This Kelvin wave was responsible for the genesis of major hurricane, but I'm not sure if it was really responsible for the genesis of Aletta, but it may have helped with the intensification.
Okay.
But now the Kelvin is over the tropical Atlantic. It's fast. It's got a phase speed of about 15 to 16 meters per second.
Right.
But the models are now, what they're doing is once it pushes over Africa and the Indian Ocean, it's slowing it down again, allowing it to recouple for convection, and we're seeing another MJO signal kind of emerge. So if you were to look at a real-time multivariate MJO index, or the RMM index, the MJO phase space diagrams, you would see the signal kind of come from the Pacific, go right through the inner circle, and come back across the African Indian Ocean. So
that's very interesting. So it doesn't just always. It's funny because as we've been doing this, massive thunderstorm complex is moving over. My office has gotten dark, and it's just like, oh my goodness! But it's like it got to night while I have a Kelvin wave over the house apparently.
Whereabouts are you located?
Wilmington, North Carolina. I was watching on radar scope as this line was sagging south, and I guess it was. Yeah. I've always thought of the MJO as kind of moving around the globe, but I guess it can kind of die out and then start over through the diagrams. And when it goes through what I call the null phase, it's not necessarily traveling so much as it's sort of dissipating and then re-emerging over here is another way to look at it. Do I have that right? That it's not, like you said, where the Kelvin wave will slow down in the vicinity of the Indian Ocean and then sort of morph into a new MJO, that's sort of the starting point.
So, yes,
but right.
So, wait, slow down. So, in that orbital phase space diagram, it's built to find these large-scale circulations that have like a wave number 1 pattern. So, an area of one area of rising air, one area of sinking air. As soon as you get a higher wave mode, you're going to see the index in the orbital PCs kind of go back into the inner circle and be weak.
Gotcha.
Now, if you were to look at a Hofmahler diagram of upper level winds, there's still a very strong signal.
Okay.
But it's moving very fast, and it's not that pure wave number one pattern.
Right.
So typically see this when the MJO translates from the Western Pacific to the Indian Ocean during specific base states. So the MJO is going to speed up, it decouples from convection, it morphs into a Kelvin wave, and then as soon as that Kelvin wave moves back over an area that's favorable for re-amplification, you'll see it slow down again back over the Indian Ocean. So this is very common, and the RMM index is very misleading because people will think, oh, the tropics is quiet now, it doesn't matter. But there's a huge Kelvin wave moving through. It's the fast mode of the MJO.
Right.
It's moving across the Western Hemisphere.
As I'm listening, that's what's...
Oh, jeez. It's a nice little slow.
It is distinct. I'm going to turn my light on. Hang on.
Okay.
I mean, it is pitch dark outside. Unbelievable. It's a little better. All right, so the Kelvin wave itself, and I know hopefully people will continue to enjoy the length of this. I'm fascinated by it. What kicks that off? Is there any definitive way to say the Kelvin wave starts because of?
Oh, so I mean, there's two theories, right? Well, the original theory is through convection.
Okay.
You have some area of organized convection that has an eastward propagating Kelvin response with equatorial velocity waves propagating back the other way. There's been some pioneer linear model studies that show this type of response. But in observations in real life, we typically see extratropical waves play a key role in generating Kelvin waves along the equator. Typically what happens is you have either some kind of cyclonic or anticyclonic wave breaking in the extratropics that then allows for extratropical waves to push near the equator, and that's where we see this Kelvin response propagate out from that.
And so these are different because we also hear Kelvin waves mentioned as coming in through the Pacific Ocean itself, creating, helping to foster El Nino.
Yes,
so they have the same names, but they're one's in the ocean and the other's in the atmosphere. And do they sometimes couple themselves, so to speak? Further complicating things.
There are oceanic Kelvin waves and there are atmospheric Kelvin waves. They have the same dynamics, but the ocean Kelvin waves propagated
true.
2 meters per second.
Right, for obvious reasons.
Yeah, it's much slower than the atmosphere. But if you think about the atmosphere, it's a fluid, right? So
right.
You have the same dynamics at play.
Right. Very, very interesting. Anything else you want to add? Where is this going in terms of maybe forecasting the potential for tropical cyclogenesis beyond the 5-day time frame? We've seen the GFS with its terrible 7-day and beyond, as Tallahassee Weather WFO called it, the GFS-icane. That notwithstanding, I think we do have a chance at least figuring out, from what I'm seeing, beyond 5 days, maybe out to 10 days, a period of favorability, and then maybe even locking in that something should develop here. And let's look and see if it does. Are we headed there, or are we still 30 years away?
Oh, no. I've been using this strategy for trader reports for a number of years now. I did an internship at Citadel, strictly just doing this, just trying to find these periods of enhanced activity. But I'm looking at 3 to 6 weeks.
Wow.
So, Kelvin waves, by theory, are non-dispersive, meaning they shouldn't attenuate. But they do change and morph around, so it's not necessarily true. So if I were to give a forecast right now based off of the Kelvin wave that's over the passing the tropical Atlantic, if this was August or September,
right,
I would be very bulled up. Let me rephrase. I would be more bulled up than I would be if it wasn't there. Right now, the base state in the tropical Atlantic isn't all that favorable. So I think we're going to see. This might be the year where it looks like you get these beautiful African waves coming off Africa, and all of a sudden just fizzle out over the tropical Atlantic.
But the further west they get, I don't know. It's just my 1985 has been coming up as an analog, and I know that it's not going to be a perfect match. But 1985 had 6 landfalls, and I saw the UK Met guidance that Ben Knoll tweeted about. Fascinating to get information for U.S. weather from a guy in New Zealand. So,
from the Hudson Valley, though.
Exactly. That's right. And I figured that out. Why he always does these snow forecasts and school closings for the Hudson Valley. I finally put those two together. But, the UK Met seasonal guidance indicating a busier, peak time of the season. It just kind of goes back to, the easterly waves may fizzle in the eastern Atlantic, but, they're not going to just go away. We're not looking at a super El Nino with just absolutely destructive shear raging across the Atlantic where these waves just dwindle to almost nothing. And so it's possible, I guess, that once we get to the climatological more favorable time of the year, August 20th and beyond really is when I look at it, and we generate these tropical waves that maybe in the Western Basin, if we were to have a favorable MJO with a favorable, I guess these are the passages of the Kelvin Wave, there could be a burst of a couple of weeks where we have a lot of activity relative to having nothing prior till.
Agreed. You see it every year. So, you will see that this year. But I just think we're not going to see the levels of hyperactivity that we've seen over the past, X amount of years.
Especially last year. I mean, that was remarkable. How it just sort of stayed on, even though Harvey was in the western part of the basin. It seemed that Harvey, and really Gert before that, sort of set everything off. And we had, I guess Franklin was the start of 10 hurricanes in a row. And that's hard to do. That's really hard to do.
I mean, specifically with the Atlantic completely changing its ocean sea structure and all the pattern.
Right.
And we do have an emerging El Nino that is on the way. Though of course it's not going to be a super El Nino, but it should still be enough of a push of warm waters in the eastern or central eastern Pacific that does generate some shear over the western Atlantic.
Now, one more question before I let you go. This talking about the El Nino, I saw that NOAA issued an El Nino watch, mainly for the winters when they're thinking that it would be its most prominent. So this term, Madoka El Nino, that, literally it's something the Japanese of different, the same but different or something like that. In 2004, apparently there was one of these more centrally Pacific-based warm events. Are you seeing any signals? I was reading today, actually, from ABC News that Georgia Tech was thinking that maybe we'd have this Madoka El Nino this year. Are you seeing any evidence of that? And if so, what could that mean for the hurricane season? Would it be more like 2004? Of course, the Atlantic was different in 2004. It was a lot warmer. There's a lot of ifs here that could happen. But if we get the Madoka El Nino, where it's more centrally located, do you think that could have some changes on later, for the hurricane season forecast, that it won't be as, maybe that's a little bit more of a favorable card?
So,
and the alerts are going crazy.
You're going to open up a can of worms here with the El Nino discussion. So every El Nino is different.
Sure.
There are
Okay.
two El Ninos
Good point. Right.
There's a spectrum of El Nino. So that's going to play in. The main thing that happens during these El Ninos, and specifically, I'll start off with Madoka. That's when you have the warmest waters near Hawaii, right?
Okay.
So all your tropical force and your convection is further west shifted, and you're not in a full eastern basin type El Nino event.
Okay.
And then the full basin El Ninos, or the eastern basins, when it's all the warmth's all the way close to South America.
Right.
You get the convection further east in location. So all the climate models that I've seen, the ECMWF, some of the CFS guidance, does suggest that the most anomalous rainfall will be west shifted.
Right. I've seen that
closer
too.
to Hawaii this year.
Yes.
So there's one caveat that I'm a little concerned with the models, and I'm not sure if they're going to handle this well, is we are in a state where a down along the oceanic Kelvin wave is finally pushing into the eastern basin.
Right, and we can see that, right.
Right, so climate models are extremely sensitive to the initialization of where these Kelvin waves were going to be. So when this last batch of climate models, like the ECWF, was initialized, the Kelvin wave was still near Hawaii or just east of there.
Gotcha.
The down Kelvin wave. Now it's in the eastern part of the basin. We're going to start to see the ENSO, all those standard ENSO 3, 4, 1, 2 indices, they're all going to have a big bump here in the next 2 months, and I suspect the climate models are going to be a little oversensitive to that, and it might over-amplify the El Nino forecast for the October through December timeframe.
And I noticed, too, that there's really not much, there's not another significant downwelling phase happening in the West Pacific. And I was looking at the subsurface animation today. It updated, I think, most recently on the 7th, the one that I look at, and where it has the animation. And you're right, it's just all propagating to the east, and there's nothing reinforcing. There's this big hole of average, if you will, in the far West Pacific. And it's like, not sending in reinforcing troops.
Right.
That warm water in the East Pac isn't going to just, it's going to dissipate naturally. There's going to be tropical cyclones, evaporation, whatever. And so that makes me kind of wonder at the strength of the El Nino, that we're not, and even the SOI to me, which is I always look at it as a good barometer, literally, as to, once it's strongly negative and stays there, you're coupled in. That's your trigger. And it's still hovering, statistically just a little bit above zero. And we're not seeing these massive drops. And I don't know, just to me, it's just not all there yet for a significant El Nino. And one last point about it, too, even the anomalies map, I really love the NOAA NESDIS, mainly because I've used it for several years, and there's just so many different methods, and you could look at CDAS and the Reynolds method, and you could do it for an hour at a time if you really wanted to. So the NOAA NESDIS East Pac, right off South America, still slightly below normal. So you're not having that tremendous warming right there off of Central America on the north side of the equator and off of Ecuador and Peru. It's not there yet. So you're right, they are all different. And how this ends up is really going to be interesting, I guess, is the bottom line. And could have a big impact once we get to late August through September. I think that goes without saying.
Yeah, so I agree with everything you said. And just to, one thing that I've been watching is ocean currents along the equatorial Pacific. And what these Kelvin waves do is they change the current from essentially east to west,
okay,
so west to east.
Sure.
So once they pass, and it's just getting to that eastern basin now, where that eastward current, I think in oceanography, it's actually called an easterly current.
Right.
If it was the atmosphere, it would be westerly. So it's a little backwards there. But once that easterly current gets to South America, you're going to see downwelling taking place along the coast of South America, and that's where you'll see all the eastern Pacific indices rise.
That'll be something to watch for. Very interesting. Yeah. You heard it here first, folks. All right. Anything else you want to add before we let you go? And I'm glad my power didn't go out with all the lightning strikes we've had.
Yeah, no, it's been great talking to you, Mark. I appreciate you asking me to jump on here. So
well,
thanks for that. Absolutely.
And as the season progresses, I'll be watching you on Twitter. Of course, you folks can follow Dr. Ventrice on Twitter. I mentioned him quite a bit. If we start to sense something happening, maybe we'll ring you up again and we can get the jump on it and, kind of see how it pans out. It's an interesting science. I appreciate it very much that you joined us this afternoon. Ladies and gentlemen, Dr. Michael Ventrice from the Weather Company, and IBM Business, right?
Yeah, that's great.
All right. Thanks. We'll talk again soon, I hope.
Okay, take care.
Bye-bye. All right. I think that worked. So there you have it. Let's get back to there he is. That was Dr. Ventrice. Fascinating. I want to start doing this more, bringing in experts in any parts of the field of meteorology, geography, even hurricane chasing. Some of the pioneers that have done a lot over the past decades. Some of us, yes, have been doing this for decades, plural. And it makes for a longer, in many cases, video, but hey, if we're learning something, I think it's all for the better. I hope you enjoyed it. All right, well, that is it for me and from me for the day. It really is interesting. It got, as you'll notice, very dark. Excuse me. Still got the cough. Get the water here. Sink water, just so you know. It doesn't taste as good. It's very chlorinated. It got very dark here as this big thunderstorm complex moved through. I'll show you real quick, and then I'll sign off for the day. That's what it looks like. Hold it up there. Hard to see, but yeah, that sucker moved right over me, and the office got all dark. My lighting got weird, but you know what? I think it worked out pretty well today. Really appreciate Dr. Ventrice taking the time to join us. I am Mark Suttoth for HurricaneTrack.com. I'll be back with more for you tomorrow.